Hi everyone, welcome to the Student the Brand. This is your Shiva sir. Today we are going to discuss about CBSE Grade 10 Physics. CBSE Grade 10 Physics. Remaining chapters. So it is continuing process. So human and colorful world we'll discuss now. So hi. Now we'll discuss about human and colorful world. Human and colorful world. Human eye. Human eye and colorful world. Colorful. So as a part of all the chapters, okay. So we are covering all the chapters CBSE Grade 10 Physics. So we are covering all the chapters in the part of that. So this is the part 3. Okay. Now we will discuss about human eye, parts and function. Human eye, parts and function. Human eye, parts and function. Okay. Now, so you are taking a lens. Lens I'm drawing. Lens. Your lens. So lens. This is the lens. Ciliary module. ciliary muscles. Okay. Here I am taking optic now. So eye diagram, now you can observe. So front portion is called cornea. So cornea, and sorry, ciliary muscles. These are ciliary muscles. So here also ciliary muscles, ciliary muscles, ciliary muscles. And here also ciliary muscles, ciliary muscles. Okay. And here, this is the iris, and people, and aqueous humor, and coming to the eye lens. So this is the eye lens, crystalline lens. Eye lens is the crystalline lens. And next one, so the entire portion is filled with liquid, so that is vitreous humor. And this one is the optic now. And here is the retina. Okay. So these are parts and function about human eye. So human eye. Okay. Now we will discuss about parts and function of human eye. Cornea is the front portion, protective layer of the eye. Most of the refraction takes place at this part, cornea. Okay, and we can see that ciliary muscles. So these are the ciliary muscles. It will hold the lens. So if you are taking, it will hold the lens. It's like this. So it will hold the lens. Okay, ciliary muscles. Whenever you are seeing the nearby object as well as far object, when we are seeing the nearby object as well as far object, ciliary muscles will adjust the curvature of the eyelid. Ciliary muscles will adjust the curvature of the eyelid so that we can able to see the near distance object as well as far distance object. Near distance as well as far distance object. So ciliary muscles. And coming to the iris. Iris is a dark muscular diaphragm. Which controls the size of the pupil. This is the iris. Iris is a dark muscular diaphragm which controls the size of the pupil. Pupil will control this gap. So this one is iris, this one also iris. Both are okay. So this gap is called pupil. Pupil will control and regulate the amount of light entering into the eye. Pupil will control and regulate the amount of light entering into the eye. Okay, aqueous humor is a jelly type liquid is present between cornea and eye lens. Aqueous humor is a jelly type liquid is present between cornea and eye lens. Okay, so this gap is filled, cornea and eye lens. So it is filled by the aqueous humor. So this entire portion is filled by the vitreous humor. This entire portion is filled with vitreous humor, eye lens and retina, eye lens and retina. This entire portion is filled with vitreous humor. Okay, and retina is a light sensitive screen. Light sensitive screen. There are two types of light sensitive cells are there. One is rod. Second one is cones. Rod sense the intensity of the light. Rod sense the intensity of the light, whereas cone sense the color of the light. Rod sense the intensity of the light and cone sense the color of the light. And coming to the optic now, what are the images forming at retina that will convert into electrical signal that will pass to the brain through optic nerve. So that will move to the brain through optic nerve. So optic nerve, all nerves will move to the brain. What are the images forming at retina? That is real and inverted image. At retina, real and inverted image will form. So two-dimensional image. So that image will convert into electrical signal that will pass to the brain. Brain will add the additional information. Brain will add the additional information, that is how much depth it is, how much height is it is, how much distance it is, how far it is, everything it will discuss. That is about so okay, retina and type of image, real and inverted image will form. So that will convert to electrical signal that will pass to the brain through optic nerve. So rod sense the intensity of the light, cone sense the color of the light. Okay. So vitreous humor is a jelly type liquid is present between eye lens and retina. This entire portion is filled by the vitreous humor. So entire portion is filled by the vitreous humor. Okay. So from eye lens to retina. From eye lens to retina. I hope it is very clear to you. So this is about parts and function of human eye. So parts and function of human eye. Once again, cornea is a front layer, protective layer of the most of the refraction takes place at cornea. So ciliary images will adjust the curvature of the eye lens so that we can able to see near distance as well as far distance. Eye lens is a crystalline lens. Whenever the light rays falls on it, converge and make it falls at retina. And iris is a dark muscular diaphragm which controls the size of the pupil. People will control and regulate the amount of light entering into the eye. Okay. And aqueous humor is a jelly type liquid is present between cornea and eye lens. Aqueous humor is jelly type liquid is present between cornea and eye lens. Okay. So it gives the sufficient blood and nutrition to the central cornea. And okay, so vitreous humor jelly type liquid is present between, it provides sufficient force and pressure to maintain that shape. Retina, so it is a light sensitive screen. Retina is a light sensitive screen. Whatever image is forming at retina, that will convert into electrical signals that will pass to the, that will goes to the brain through optic nerve. Rod sense intensity. Rod sense the intensity of the light. Cone sense the color of the light. So that is about human eye part. Human eye parts and their functions. Right. Next one, myopia will discuss. So refractive defects. When light ray falls on it, if the lens does not refract properly, so through lens, refraction takes place. In the previous class, so you can see part 2 explained about lens. So this is part 3, so you can check once part 2. Okay. Myopia and hypermetropia. Myopia is nothing but myopia. The person can able to see near distance, he can't able to see the far distance object. The person can able to see near distance object, you can't able to see the far distance object. For the correction of myopia, we are using concave lens. Myopia, myopia, myopia. Myopia, myopia, myopia. Near distance we can see, far distance we can see. Myopia, myopia, myopia. For that correction we are using bro. What bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. So myopia we can able to see near distance, we can't see the far distance. For that correction we are using concave lens. So I'll give one small incident. So how you are okay. So what is myopia? How to draw myopia in the form of diagrams? Okay. How it will be corrected? Now you can see here. This the person, myopic person, the person who has myopia. So you can see 25 centimeter, nothing but the minimum distance up to which a person can able to see, or the minimum distance up to which the person can able to see distinctively, means without any problem. So you can see the minimum distance up to which the person can able to see clearly, that is a 25 centimeter. So if you are taking 25 centimeter, you can able to see until 25 centimeter clearly. So beyond the point you can see, but below that point you can't see the minimum. So if you take 25 centimeter, that is a near point, that is a fixed point, near point. Okay, beyond the point, beyond 25 centimeter only we can able to see, so like a 10 centimeter, 5 15 centimeter, if you place any object, so if you place very close to the eye, so we can't able to see, properly. Okay, if you place near to that, our eyes will get strain and pain, because we can't able to see the objects. So certain distance if you place, we can able to see. So if you are taking 25 centimeter, at 25 centimeter we can see, beyond the point also we can see, so below 25 centimeter we can't able to see. So that's why near point is nothing but the minimum distance up to which a person can able to see clearly without any strain or pain, that is called near point, 25 centimeter. The maximum distance up to which a person can able to see clearly, maximum distance up to maximum distance is infinity. So minimum distance is 25 centimeter. Range of vision is 25 to infinity. Range of vision is 25 to infinity. We can able to see 25 to infinity. We can able to see. Okay. Now you can see here myopia. So we know that, as I said, 25 centimeter you can see, but infinity you can't see. Between this point, somewhere else you can see. Far point of myopic person is less than infinity. So it will be less than infinity. So less than, far point of myopic person is less than infinity. It is not infinity point. So less than infinity it will be. Okay. So okay, once again, the person can able to see near point 25 centimeter, you can see 25 centimeter you can see. So you can't see infinity point, but between infinity 25 to infinity you can see. Between 25 to infinity you can see. So that point, so we can see this point. Now, if the light rays are coming from this point, how it will be? Light rays are coming from this point, how it will be, and we have to correct this defect. So finally, we want to see the far distance object. That is only our target, right? Finally, we need to see the far distance object. How we have to see, how it will be corrected? Just check it once. I will draw the diagram. Okay, done. Mhm. So here light rays are coming and meeting. Mhm. Mhm. So as I said, light rays are coming from far point, you can see. So if the light rays are coming from this point, the person can able to see. Here you can see. This is a near point, far point. So now, if the light rays are coming from infinity, you can't see, but where the light rays will meet, we will see. So here the dotted lines represent light rays are coming from infinity. Dotted lines represent light rays are coming from infinity. So we are using concave lens. Concave lens. Okay, so now you can observe here. This is the far point of so here far point of myopic eye. Myopic eye. So this is the myopic eye. Myopic eye. And this one is the correction of myopia. Correction of myopia. Correction of myopia. Correction of myopia. Once again, observe here. Observe. Here light rays are coming, as I said, if the light rays are coming from far point, so we can able to see. If the light rays are meeting at far point, at retina, so we can able to see. Light rays are meeting at retina, we can able to see. So here you can observe, light rays are coming from far point, so those light rays are meeting at retina, so we can able to see. Here you can see, light rays are coming from infinity. Light rays are coming from infinity. Those light rays are meeting in front of the retina. That is the reason we can't able to see. Here you can see. So light rays are coming from infinity. So concave lens, this is a concave lens. After refraction, so the light rays will meet at retina. Okay, so this is the correction of myopia. Correction of myopia. I hope it is very clear to you all. Far point of myopic eye. Myopic eye. So if you observe this middle diagram, so you'll get to know the causes of myopia. You'll get to know the causes of myopia. What are the causes of myopia? Okay. So first point is causes of myopia. You'll get to know if you observe the middle diagram. So second diagram, if you observe, eyeball is too big. Eyeball is too big. Eyeball is too big. Focal length is small. Eyeball is too big. Focal length is small. So those are the two causes of myopia. So if you observe the medial diagram, you'll get to know the causes of myopia. Okay. So very, very important. What are the diagrams I drew on the board? So three diagrams you have to remember, you have to practice. Understood? So far point of myopic eye, correction of myopia. Right? So check once observe the diagrams. Next, I will explain about hypermetropia. Here you have to show that diverging nature, because concave lens is diverging nature. Okay, so you have to show that this one. This is about myopia. Coming to hypermetropia. 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 Far a distance we can see, near distance we can see. Hypermetropia. 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 Further correction. We are using We are using convex lens, convex lens, convex lens, convex lens, hypermetropia, 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 hypermetropia. For a distance, we can see. Near distance, we can see. Hypermetropia, 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 hypermetropia. For that correction, for that correction, we are using convex lens, convex lens, convex lens, convex lens. Okay, so like that. So that is about hypermetropia. Now I'll draw the diagram. So just check once. Hypermetropia, 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 hypermetropia. Hypermetropia. So hypermetropia is nothing but the person who has hypermetropia can see far distance object 25 centimeter. This is infinity. Hypermetropia means the person can able to see the far distance object, he can't able to see the near distance object. Okay, so but between 25 to infinity you can see, that is n dash. You can't see this one, we can see. So this one we can see. If the light rays are coming from here, so we have to correct this one. We have to correct this defect. Okay. So infinity you can see, somewhere between 25 to infinity you can see. So you can't see the 25 centimeter, the person who has hypermetropia. Now we will draw the diagram. So whatever I explained in the format of concept, how to draw the diagram we will see now. Okay. Now hypermetropia, 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 hypermetropia. Hypermetropia, 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 hypermetropia. So if the light rays are coming from near point, you can see. So I'm taking light rays like this. So this is N and this one is the N dash. So this is the N. If the light rays are coming from this point, so where the light rays will meet? So light rays will meet beyond retina. Okay. So convex lens I am taking. Convex lens to correct the defect of my hypermetropia. We are using convex lens. So after again it will be converging. Okay, so here we are extending the light rays. So at n dash those light rays are meeting. So this is n dash. This is the near point of hypermetropic eye. Near point of hypermetropic eye. Hypermetropic eye. And this is the hypermetropic eye. This one is hypermetropic eye. Hypermetropic eye. Hypermetropic eye. This one is the correction of hypermetropia. correction of hypermetropic eye. Hypermetropic eye. Okay, so check once here. Once again, observe carefully. Observe carefully here. Near point of hypermetropic eye, correction of hypermetropic eye. As I said, hypermetropia, 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 hypermetropia. For a distance, we can see. Near distance, we can see. Hypermetropia, 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 hypermetropia. For that correction, we are using convex lens, convex lens, convex lens, convex lens. So we can see far distance, we can't see near distance. For the correction, we are using convex lens. So by seeing the second diagram, we'll get to know that. So by seeing the second diagram, we'll get to know the defects of hypermetropia. Defects of hypermetropia, that is, eyeball is too small, focal length is too long, like a causes of hypermetropia, that is nothing but causes. So eyeball is too small, focal length is too long. Eyeball is too small, focal length is too long. So these are the causes of hypermetropia. Okay, so that's enough. This is about hypermetropia. I hope it is very clear to you all. Right? Yes. Next one. So those who want to interact with me, so I given a Instagram page. Okay. So in the description you can find out. You can check in the description. So below this video. Okay. So you can like, share and follow my Instagram page. And if you have any, you can contact with me through Instagram. So I'll respond to your questions. So if you have any doubts, you can ask me through Instagram page. So I given in the link below. So go and check my Instagram page. Okay. Done. So now colorful phenomena. So till now we discussed about eye parts and function, myopia, hypermetropia, and coming to the one more, presbyopia. Presbyopia is nothing but the person can't able to see near distance as well as far distance. The person can't able to see near distance as well as far distance. To correct the defect of to correct the presbyopia, the person can't able to see near distance as well as far distance. For the correction of presbyopia, we are using bifocal lens. Upper portion is concave lens, lower portion is convex lens. And coming to the cataract, a milky and cloudy will form on eye lens. So that will be corrected by laser surgery. And one more thing, astigmatism. We can't able to see horizontal lines as well as vertical lines. We can't able to see horizontal lines as well as vertical lines. That is astigmatism. So by using suitable cylindrical lens, we can correct the defect. By using suitable cylindrical lens, we can correct the defect. Okay, that is astigmatism. And so this is about defects. And coming to the prism, refraction through prism, will discuss refraction through prism. Okay, so those who are new to the channel, please do like, share, and subscribe to Student in the Brand. You can inform your friends, ask them to join to the class. Once see my YouTube channel, go and watch my YouTube channel. You'll get to know there are many videos, lot of videos related to physics. Okay, so nearly 4,000 plus videos are there related to physics subject. Go and check once, watch once. If you like it, you can subscribe my channel. You can share my channel. You can inform your friends, ask them to join to the live class, listen to the class. Those who have any doubts, my Instagram page I given. So link is given in the description. So check in the description. Okay. So if you have any doubts, you can contact through me through Instagram page. So you can follow the Instagram page, right? So chalo, fight. So I'm taking the prism like this. Prism. Light ray is passing. Light ray is passing like this. So incident ray, refracted ray, emergent ray. So if you are extending angle of deviation, and if you are drawing the normal line, and the angle between incident ray and normal line is called angle of incidence. Angle between refracted ray, emergent ray and normal line is called angle of emergence. Angle of emergence, and this is called angle of deviation. Angle of deviation. So angle of prism, capital A. Okay. So this is about if the light ray is passing. Trace the path of the white light ray. Trace the path of the white light ray means you have to do this one. So you can draw like this. So here if you are taking like this, it passing through like this. Okay. And so how dispersion takes place? Well, white light ray passes through the prism. How dispersion takes place? So we will discuss now. Okay. Now you can see here when the light ray passing through the prism. So how dispersion takes place, we'll see. So it's split into 7 colors. 1, 2, 3, 4, 5, 6, 7. Again 1, 2, 3, 4, 5, 6, 7. So those 7 colors: violet, indigo, blue, green, yellow, orange, red with GR. Violet, indigo, blue, green, yellow, orange, red with GR. Violet, indigo, blue, green, yellow, orange, red. Okay, so check once here. Violet, indigo, blue, green, yellow, orange, red with GR. When white light ray passes through the prism, split into 7 colors. So the phenomena of splitting of white light into 7 colors is known as dispersion. Dispersion. Dispersion is nothing but splitting of white light into 7 colors. So second one is spectrum. Spectrum. The band of colors will form like a screen on the band of colors. Here you can observe the spectrum. 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 Dispersion. Dispersion is nothing but splitting of white light into 7 colors. 7 constant colors is known as dispersion. Spectrum is nothing but the band of colors will form. Okay, so the 7 colors will form like a band is known as spectrum. The band of colors is known as spectrum. Splitting of white light into 7 colors is known as dispersion. Okay, so when white light passes through it, so based on the wavelength and the refractive index, based on the wavelength refractive index, so light rays will split. So violet deviate the most, red deviate the least. Okay, that's the reason. That is the reason you can observe danger signal. Okay, danger signals are in red in color. Okay, so red color. So it deviate very least by smoke. Okay. So that's the reason for far distance also. From far distance also we can able to see the red color. Right? Yes. Now, actually Newton split the colors into 7 colors. He sent the white light through prism. So those 7 colors will split. No, so white colors will split into 7 colors. So in lower classes you can see 6th, 7th and 8th classes, I hope. Okay, so you can paste all the 7 colors. So violet, indigo, blue, green, yellow, orange, red on the disc. And if you rotate, it appears white color. Okay, so all colors will be mixed. So we can see the white light. Okay, so it appears white color. White color, right? Yes. Now, so Newton sent the light ray through prism. It's split into 7 colors. Still further, okay, still you want to split the colors. Split the colors into, okay, further. So still you want to split the color. Then what he did, see, place the prism. So nearby this one. Next one is recombination of spectrum of white light. So this is the refraction through spectrum, refraction through prism. Next one is so further you want to split the colors. So normally you place like this. So 7 colors: violet, indigo, blue, green. So 1 and 7 colors. So you place a normal prism. So you actually place like this. So what are the 7 colors came out? Those 7 colors as it is there. So what he did, he placed the inverted prism nearby the first prism. Inverted prism nearby the first prism. Then all the 7 colors again combined, all those 7 colors combined again. So we got outcome as a white light. So you can observe here. Okay. So this is the first prism, prism number 1. Prism number 1, prism number 2. So white light, white light, white light. So outcome as on screen also white light only. White light. Okay. So observe carefully. This is a recombination of spectrum of white light. Recombination of spectrum of white light. Recombination of spectrum of white light. Spectrum of white light. Okay. Recombination of spectrum of white light. I hope it is very clear. Right, once again observe. So white light passes through the prism, so it's split into 7 colors. Those 7 colors will form on inverted prism. Again it is combined. Those 7 colors will be combined and form as a white. So we can see the outlet as a white light. So this is the recombination of spectrum of white light. I hope it is very clear to you all. Right. Next one. Now we will discuss about rainbow formation by water droplet. Rainbow formation by water droplet. So I'm taking a water droplet like this. So light ray is passing, so it's split into 7 colors. Okay, so here. Okay, you can observe. So what is the phenomenon involved in the formation of rainbow is refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. Internal refraction, dispersion, internal reflection. So this is the phenomena involved in the formation of rainbow. How? So once again here, this is the red light, white light, violet, red, violet, red. Okay, so this is the white light. White light. When white light passes through the prism, water droplet, white light passes through the water droplet. So it's split in. First refraction takes place, then dispersion, then internally reflection takes place. Internally reflection takes place, then outcome as a rainbow formation. Rainbow formation. Okay. So until here, I hope it is very clear. So those who are new to the channel, please do like, share, and subscribe to Student the Brand. And you can check my Instagram page. So it is given. Link is given below. So you can check once and follow the Instagram page. And if you have any doubts, you can ask me. So related to CBSE Grade-10 Physics. Okay. And so I already started the assessments. So you can check daily. Okay, I'll follow the in community post. So I'll upload. I'll post. So check once in community post. I'll post every day. Okay. So just check the community post every day. Then you will get to know the updates. And if you like and share and subscribe my channel, then you will get every day, every update you will get it. So thank you so much for joining and attending and listening my class. Still it is there. So again, we'll take one short break. Still further it is there, like colorful phenomena. So about those points we'll discuss. So I hope this is a part 3. So once you go and check the part 1, part 2, and part 1, part 2. So this is a part 3. So all CBSE chapters, CBSE Grade-10 Physics chapters. So I'm doing according to the part 5. Check once. Thank you so much. This is your Shiva sir. We'll see you in the next class. Thank you.